Hello, welcome to tutorial number 4. In this tutorial we are going to be adding the ability to shoot and destroy enemies, and we are going to be optimizing some things in the game. We might be able to get to particle effects in this tutorial. We'll see what happens. Okay. So I figured out is I have 2 bullets. So if I search bullet, I see my TSCN, and I have a player bullet and a normal bullet. And I think I kind of went over this before. So if you do have a normal bullet, do not delete the player bullet. You want to delete the normal bullet, the one that you're not. You can check which one to delete if you named them differently. It's re-preload the player bullet.tscn, so make sure you don't delete the bullet that gets preloaded. So right now we have duplicate bullets, which I don't know how that happened, but again, I'm not sure if this happened in the tutorial series. It might have happened just because I was going through the project after the tutorials. So right now I'm gonna test the game. Now we deleted the bullet, it still works, and we can shoot bullets. So now what I'm going to do is we're going to be able to detect when a bullet is going to be hitting an enemy. And so we're going to open our bullets scene right here, or player bullet one, or whatever he called it, that the player is shooting, and go to node right next to the inspector. And it has some predefined signals. Make sure we have our hitbox detected and not our sprite. And then each node has different signals attached to it that are built into it. Our area is going to detect if another area is colliding with it. And you can see our player, actually no, we're testing if our enemy hits it. So open your enemy that we have, and we need to check if the player bullet hits the enemy, and they're both using areas. So what we can do is go in our player bullet thing, do area entered to the area. That's a built-in signal. We press connect. Make sure you connect it to the node that we have the script attached to. In this case, we have it attached to our sprite player bullet, and you should have it attached to the player bullet sprite. So just select player bullet. And we don't need to change the method. It auto generates the function method. We'll press connect. So now this detects if an area enters this area. So if another area comes into this area from the node, and the size of the area is defined by the collision shape under that. So this area is as big as the collision shape, and the same as the enemy too. So I'm going to so this variable area will get the other area that it finds. So if we can check what the area is, so we can do if area dot get name or something like that. Just do like enemy 1. Then we know like which area we are getting. We make sure we know it's the enemy. The problem with this method of getting the name is if we add in other enemies, it's not gonna work with them, and you'll have to do or area.getName enemy 2 or enemy 3. It gets super inefficient. So what Godot supplies is go into your enemy. It supplies a group system. So we're gonna go to our group. We're gonna call this enemy, and we are going to add it. And I think I'm gonna do this differently. So I was gonna have it so the bullet detects if it hits an enemy, but the problem is we're gonna have like health systems in the enemy and stuff. So we actually want the enemy detect if it hits the bullet. So then we can execute all that code in the enemy, because we're going to have a lot more code in the enemy that we're executing other than the bullet. And so we're going to have to call the whole ton of code back to that enemy. So that's going to become inefficient. So I'm actually going to disconnect this right here. and I'm gonna remove this function. I'm gonna resave this, and let's go to our enemy, and we don't really need the enemy group yet, so I'm just gonna delete that too. We're gonna connect this to our area enter to our enemy script instead. So now we have that connected, and now we're gonna add go to your player bullet. I'm gonna go back to 2D so I know I'm in our player bullet. I'm gonna set a group called enemy damager, and this group it's gonna check is these are all the objects that'll damage the enemies. And you want to make sure the groups are attached to the hitboxes, because remember that we are getting the group from the hitbox is our area. So it needs to be attached to the hitbox or else it's not going to find that. If area, we are mentioning the area we are colliding with, dot is in group enemy damager. Make sure you have the group name correct. If you don't, it will not find that group, so it has to be the correct name. And if we will be checking if it is, and if it is, we want to do area.queueFree. So what queueFree does is it deletes the node, basically just remove it from the game. The problem is if we do area.queueFree, it's just destroying our hitbox. We're going to still see our player bullet though, because the sprite is above it and it's not deleting our sprite. So we need to do area.getParent. What getParent does is it gets the node above it, and it'll see, oh, we want to get our player bullet node, and we're going to want to queueFree it and get that destroyed. And then after we destroy our bullet, we want to destroy the enemy, so we just do queueFree. That destroys our enemy. And we will do like health systems and stuff, but for right now, we're just gonna queueFree the enemies. And we can run that now and see if that works. We have our player, he shoots, and the enemies get destroyed. Looks good. So the only thing about it is the enemy doesn't really feel like shooting an enemy doesn't really feel that like good to play as, because it just gets destroyed, just disappears. It doesn't look that good. And so what we can do is particle effects. And so what we're going to do is press the plus button to add a new empty scene. We're going to do custom node particle. We want to do CPU particles 2D, because remember we're on GLES 2 and this is like the optimized particles. We're not going to use particles 2D because right now we're using GLES 2 for like HTML5 and stuff, if you guys want to do that and put it on like a website. So we see we have our particles, and actually before we do our particles, let's not save this yet. We need to optimize everything. So when I run the game, I'm going to go over to remote and still open this. And what remote does, it shows the nodes that are actually actively running in this game, other than what's running on the engine so far. You can see all these enemies are getting created, but they aren't being destroyed. They're just being calculated forever past the end of the screen. And once the enemies pass the end of the screen, we don't need them anymore. Like, they don't need to exist anymore, 'cause we're not actually actively going to be using them at all. So what we're going to do is we're going to check if the enemy is too far off the screen, and then we're going to destroy it. So go to enemy, and we're going to do in function underscore process, we want to do if global underscore position dot x is less than -20. So the corner of the screen is at 0, like all the way to the left side of the screen is 0 in the game engine. And so -20 is past the left side of the screen, the part where we can't see, all the way to the left. So that means that he's outside the screen. Then we want to do Q free. Okay, so now I'm gonna run the game. I'm gonna go into remote, so we're seeing the game as it's running. See, our enemies are being created and they are being destroyed. They aren't stacking up. So let's see if our bullets are getting destroyed. You see, our bullets are having the same problem. They're just going on forever without ever getting destroyed. So what we want to do is we want to go to bullet, player bullet, and you want to do if global underscore position as .x is greater than 180. So 160 is all the way to the right side of the screen, but if we destroy them right on 160, because that's our window size, if we destroy them right there, you'll see them being destroyed. So we're going to go past that to 180 to give it some time to actually go fully past the screen. We're going to do Q free. So now if they get past that position, they will be destroyed. So I'm going to go back to remote to see what's actually happening in the game. We have our enemies being created, they're being destroyed, our bullets are created, and our bullets are being destroyed. So now the game is it's now more optimized. So now you can play it longer without processing power going up a lot. So now, yeah, that should be a lot better on the computer. Okay, so now we're gonna do CPU particles. And we're gonna make some particles that come out of the enemies when they explode. So I'm gonna rename these particles to enemy destroy particles. Okay, we don't really want gravity on them though, because this isn't really a platformer game. It's more of a it's in space, so we're gonna kind of do, let's see, and this is gonna be an explode, so we need to set explosiveness up to 1, and so it kind of goes in bursts now. And I'm gonna change the amount. Let's set the amount to like 12 or something. And the thing about these particles is you kind of are just slowly adjusting values until it looks right. So we're gonna go through the values pretty quickly. I'm trying to figure out what I want to do next. Okay, gravity, we want to set that to 0. And we'll see what, now they don't really have very much velocity right now, so we're gonna set our initial velocity something higher, like 5. 10 maybe. They're all going to the right now. I can see that. So what we might be able to do is our emission shape. So the emission shape is a little point creating all of these little particles, but we want kind of a sphere thing creating them all. So it creates a more of a dynamic kind of range around them. Spread, so this is what's causing it to all go to the right. We want to set spread to 180, so it goes 360 all the way around. So now we have our particles kind of exploding. I want to make sure this is up to scale, because you can set up your particles, but sometimes you might be like super zoomed in and not to like the correct size. You see our room's like this big, and so I'm going to actually add a sprite as the child node. And this is not going to be in there later. This is just going to be for to see like how big it is compared to the enemy. So you can see those particles are actually really small compared to the enemy. And what we can do is we can do actually, you could see like, I'm probably going to set the scale to like 2. But I kind of want the scale to go down the longer it's alive, because you can see that they just kind of disappear. It doesn't look smooth at all. I'm probably going to give it more lifetime too. I'll give it like 1.5 so it stays longer. And let's see. Yeah, scale. We want to do the scale amount curve. And I'm going to do new curve. And you see we have a curve right here on our inspector, and you can just click it to start editing it. So our max value will set to 2 because we have our scale amount to 2. And so this is over the time period, is at the bottom. And so what I'm going to do is I'm going to click right here. Do right click at 2, add a point. I'm going to move this up all the way to 2. And it looks like, let's not set our scale amount before that, because I think that just doubles it when you have that. And we'll set it all the way to 0 at 1. Now you can see that they kind of are scaling the entire time, but I don't really want that. I want them to start scaling like pretty far into the animation. So I'm going to do this and drag up a point at like 0.75. I'm probably going to move it back a bit. It's just a matter of like fine tuning it all. Okay, that looks pretty good. You could do like whatever you want to do for the particles. It doesn't have to be exact, like whatever you think looks good. I'm just doing what I would think would look good. We're actually going to set angle to random to like 1, so this will randomize some of the stuff that we put in the values. And actually we can leave this in, but I'm going to set it so we have an angular velocity, so they're kind of spinning sometimes. And so let's set it to like 2 or something. I don't know, let's try it. And let's set it to 1 for random. Let's go like 10, 20. I'm just going to move this up a bit. Yeah, I like that. So this is basically what our particles are going to look like. But I'm going to kind of give more... I'm going to leave the particles white for now, and then I'll probably change them later. Yeah, I'll just change them later. But we can remove our sprite now. That was just to see the scale. And now we just have our particles. So we're going to save this as a scene. Press Control S. Now we have our scene, save it, and now we're going to instance this once an enemy dies. So let's see, let's find our enemy, one scene, and in the script we're going to have to do, I'm going to scale back my inspector a bit so I get more room. Global position. So I think in the enemy, what we're going to need to do is we're going to have to set up a signal when the enemy dies to create a the particles to destroy. So what I'm going to do is signal create enemy destroy particles. And we're going to have our particles that we want to create and our location as our parameters of that. And we need to preload the particles that we want to create. So var particles equals preload. And make sure that you preload, not enemy generator. Make sure that we preload our enemy destroy particles. Make sure it's a TSCN file, so it's a scene. We're actually preloading the scene, and when the hitbox is entered with an enemy damager and we're destroying it, we want to emit our signal, create enemy destroy particles, and the particles we want to create is our particles that we set up here, and our location we want to be our global position. Okay, so now we're going to have to connect this signal with the world. But the enemies, you can see that the enemies will be instants outside of the world, and we can't just connect them. We can't just manually connect them like this. We're going to have to connect them through code finding the world scene. And this is where our singletons are going to come in handy. So go to project settings, and we're going to go into auto load. Before we do this, we actually need to make a script for our singleton. And what singleton does is it's like a node like our world, but it'll stay outside of our world, and it'll run in every single scene of our game. And we're going to create like a global kind of node thing. So make a new script. We're going to call it global.gd. And singletons are actually really nice to use when creating like your own like custom functions that could be run anywhere in the game. And so now what we're going to do in our world is we're going to set a variable, and not in our world, in our global. We're going to set a variable called world, and it's going to set, we're going to set it equal to null. So now we need to set it so our project actually auto loads the script in every single thing in our game. So go to our project settings, go auto load, hit this little folder icon, and we are going to hit world.tsc, not world, sorry, global.gd script. And we'll leave it name as global, and we're going to do add. And now it's our singleton, and it's going to be auto loaded in every single scene in our game. So now, the reason why we set a world in here is other than trying to directly get a node, we're going to use the singleton to get it. So then we're not relying on other things in our game. Because it's nice if you rely on only one node, that'll always be there. Other than relying on multiple nodes that won't be there to get data from. And so we're not just going to look through for our world node in our enemy. We're actually going to set it in our global singleton, and then our world will set it to itself after that. So I'm going to save it. In our world, we're going to do function underscore ready. And what we're going to do is we're going to do global. So now we're referencing our singleton script, and we're getting the variable world. .world, we're going to set it equals to self. So now we have the direct position of the world in the scene tree without directly getting it in our global. And now we're setting it to our global script. But what happens if this world, if we go into a new scene without this world, and we're trying to reference it in our enemy, but there is no world, and it's already set to self? Well, what we have to do is function underscore exit tree, and so if the game gets restarted or you move to a different scene, this will make sure that we set global.world back to null, so we know it doesn't exist anymore. Now, yes, save this, and we're gonna go back in our enemy, and when we emit our signal. Actually, we can do this in our world. When we emit the signal, actually, no, we need to connect it. That's what we're doing. I forgot. So we're going to make a ready function that happens when the node is created. And we're going to do connect, create enemy particles, the node that we want to connect, to the object we want to connect it to, and we want to connect it to our world, so do global.world, and we want to do the name of the script, of the function, sorry. So we're going to call it underscore on create enemy destroy particles, like that, I think. Yeah. I'm just gonna copy this. And I think that's the same way it's formatted in our world. Let's go back to our world. Oh, it has a capital on the second one. I'm just trying to format it the same way it sets it. So now we're connecting this signal back to our global.world, and we're setting the script name to that, but we still need to make the function before this happens. So we need to already make a function for the world, or else this just this is useless if we don't do that. So what I'm gonna do is, first we need to check if the world exists. So do if global.world is not equal to null. If it's not equal to null, that we know it exists, and we can connect it. Because if we try to connect it and it doesn't exist, we can get errors. So we're going to check if it does exist first, by checking if it's not equal to null. Okay, so now we are going to go into our world, where we have our function to create our particles, and we also need to put in the parameters. And when I connect it, I think I need to put in the parameters in here too. So I would do, wait, let me look at this first. Yeah, I think we put in the parameters. So the parameters we want, our particles and location. Yeah. We might not need to put these in. I can't remember, but we'll do that anyways, and we'll see what happens. So we have our parameters, particles, and our location. So do var variable particles instance equals particles dot instance. Now we get a reference from it. We're gonna add it as a child of our world node, which we're in right now. Our particles instance, and we're gonna set the location. Actually, particles instance dot global position equals location. And now we have our function to create our particles, and in our enemy we connect it, because we can't just connect it through here because the enemies will always be instanced, and that's why we can't just manually connect the signals. And so this should work now that we connect them. And it looks like we are getting errors. Let's look at this. Error calling method from signal on create particles location method not found. Let's see, emit signal. It's not finding this method. Should be. Maybe it's because it's connecting wrong. Right? I think it's because it's connecting wrong. So this should be working down here. I don't think I need these then. Yeah, there we go. That was the thing. And you'll see our particles will actually replay, and we can fix that by doing a timer under our particles. So I'm going to open back our particles, and you can see by the lifetime is 1.5. So I'm going to add a child node timer, and we're going to set the wait time to 1.5, just like the particle time. Put it on auto start. I'm going to create a script, and I'm not actually going to call it the same thing. I'm just going to call it destroy particles, because we're going to use this for multiple particles systems in our game. So I'm just going to call it destroy particles, and it's going to be the exact same script. Create. Now we have this in here. We can delete all this. Go our timer, timeout, and our signal, and you want to connect that to our enemy destroy particles. Don't rename the method. Press connect. Now it's here. Okay. I'm gonna remove this, and we're just gonna do Q free. So now when it times out, we destroy the particles. So now when I run the game, I shoot it, and they get destroyed. The particles kind of are a little bit long lasting, so you can edit the parameters. I'm probably gonna do is I'm just gonna set the time back to like 1 second, and then set the timer to 1 second, and I'm probably just gonna set the velocity even more to like, I don't know, 30 or something. Yeah. And then you have these awesome particles that happen when you shoot the ships. And you can mess with the velocity random. You can do like 0.5. And so they'll actually move at different speeds now, which makes it look a lot better. And there we go. We have our enemies getting destroyed. We have optimized it. And we have our particles in. So thanks for watching this tutorial. I hope you liked it, and I hope you learned something new. And I'll see you in the next one.